Good morning all. In previous session we have seen voltage to current converter. We know that voltage to current converter is the thing, but it produces an output current which is proportional to its input voltage, that we can call as voltage to current converter. So this can be classified into categories depending upon the position of the load that we have seen, that is voltage to current converter with floating load and voltage to current converter with the grounded load. Now here we are going to see current to voltage converter. The op-amp circuit which produces an output voltage which is proportional to its input current, that we can call as current to voltage converter. I repeat again, the op-amp circuit which produces an output voltage proportional to its input current is called as current to voltage converter. Now here we can observe the current to voltage converter circuit diagram. Now we can note that this circuit is a special case of inverting amplifier. So the open loop gain of this circuit, that we can consider as AV, that is very large. So as per the concept of the virtual short, we can say voltage V1 is equal to voltage V2. So input impedance of the op-amp we can consider as very high. So if the input impedance is very high, therefore the currents entering into the two input terminals is very small. We can say IB1 is equal to IB2 is equal to 0. So the current flowing through the inverting terminal and current flowing to the non-inverting terminal, both we can consider as 0. So the gain of the inverting amplifier can be written as AV is equal to minus RF by R1 is equal to VO by VN. So we can write VO is equal to minus RF by R1 into VN. So we know that V1 is equal to V2 and V1 is equal to 0 as the non-inverting terminal is connected to ground. Therefore V2 is also 0. Thus the inverting terminal is also at the ground potential and the entire input voltage appears across resistor R1. So we can say IN is equal to VIN by R1, or we can say VIN is equal to IN into R1. Therefore we can write VO is equal to minus RF into IN. So if you see this equation, it indicates that the output voltage is proportional to the input current IN. Thus the circuit which is shown here, that converts the input current into the proportional voltage. If you go for the sensitivity of the I to V converter, then as we have seen, the output voltage is equal to VO is equal to minus RF into IN as per this formula. Hence the gain of this converter is equal to minus RF, and the magnitude of the gain, that is RF, is also called as sensitivity of I to V converter, and the amount of change in the output voltage delta VO for a given change in the input current delta IN is decided by the sensitivity of the I to V converter. So by keeping this RF variable, it is possible to vary the sensitivity as per the requirement. We can say there are two possible problems in the I to V converter circuit. That is, there is a possibility of closed loop instability, the accuracy of conversion that depends on the introduction of drift errors. So these errors should be reduced. And when you go for the high sensitivity I to V converter, then the gain or scaling factor, it can be increased by increasing the values of resistances used in the I to V converter. But high value resistances tend to be less stable, and sensitivity of I to V converter, it can be increased without using very high value resistors by using a resistive T network in the feedback path. As we have seen, VO is equal to minus RF into IN, where RF denotes the sensitivity of the I to V converter. Hence we may think that to increase the sensitivity, we have to increase the value of RF to an indefinitely high value, but the high sensitivity I to V converter that proves that such a things need not to be done. So if you go for the applications of the I to V converter, then we can say it is used for sensing and measuring current through photocell or photodiodes. In a light intensity meter it can be used, and in digital to analog converters also it can be used. Now we have seen that current to voltage converter, that is the circuit which produces the output voltage that is proportional to its input current, that we can call it as I to V converter.